Hello, greetings, and welcome to your final freshman year algebra class. Hope that you guys have had fun. Today, we are going to compare linear, exponential, and quadratic models. All right, so we're going to answer this question at the end. How do I decide whether a linear, exponential, or quadratic model best represents the data that I'm shown? All right, so this year, you guys have learned about three types of function: linear, exponential, and quadratic functions. All right? So linear function is linear, so it's just going to be a straight line, and it can be represented as y equals mx plus b. An exponential function is going to show some kind of growth and will be represented as y equals x, or y equals ab to the power of x. And then quadratic function is what we have been working on most recently, y equals ax squared plus bx plus c. And remember, quadratic function is not going to be linear, and it's going to kind of give you a U-shape or a parabola, or a parabola, if you will. All right, so make some observations. How are these functions the same, and how are they different? So take a moment to pause the video and just make a couple of notes of what you see. Alright, so hopefully you notice some differences in the way the graphs look, and also the equations. Alright, so let's look at this real quick. Guided practice. Use a graph to tell whether the ordered pairs represent a linear function, an exponential function, or a quadratic function. Alright, so all you need to do is just plot these points. All right, remember, or don't remember anything. Well, remember everything, but not in particular for this. All you need to do is plot these points here for each of the graphs below, and then tell whether it's a linear function, exponential function, or quadratic function. So go ahead and pause the video and do that on your own. Alrighty, so that's what they should be looking like. And first is an exponential, second is linear, and third is quadratic. Alright, so how do we tell the difference? How do we tell which one is which if we're given a table with the coordinates? Alright, a linear function is the differences of successive y values are equal. So here's our y values. What's the difference between these two y values? Well, 5 minus 2 would give us 3. Difference between 5 and 8, again, would be 3. And the difference between 11 and 8 would be 3. So we see here that our differences of successive, right, they're in order, successive y values are equal. So that's how we can tell if, just by using data from a graph, whether or not it's linear, exponential, or quadratic. For exponential, ratios of successive y values are equal. All right, so we have a ratio of, again, the successive y values. So 0.5 over 0.2 would give us a ratio of 2. 1 over 0.5 would give us the same thing, and then 2 over 1 would give us the same ratio of 2. So because of that, we know that this function right here would be an exponential function. And then lastly, quadratic function, the second differences are equal. All right, so let's look at this real quick. So the difference between 5 to 2 would be negative 3. Difference from 2 to 1 would be negative 1. Difference from 1 to 2 would just be going up 1, and the difference from 2 to 5 would be positive 3. Right? Those are our first differences right there. That's not what we want to look at, though. We need to know what it is, but that's not what we look at to see if it's a quadratic function. We have to look at the second differences. All right? So our second differences would be the differences of the first differences. So what's the difference between negative 3 to negative 1? It's going to be 2. The difference between negative 1 to 1? 2. And then the difference between 1 to 3 is going to be 2 as well. So because of that, we know that this function right here would be a quadratic function. All right, so look at the guided practice on your own, and let's see, which ones do I want you to do? Okay, yeah, do the number 2, 12, and 13 that's on your page, and pause real quick, work those out, and then check yourself. All right, so first check if it's linear. See if the differences of successive y values are equal. All right, so 0.4 minus 0.008 gives us 0.32. Then 2 minus 0.4 gives us a 0.16. So we know that those are not the same. They're not equal differences, so it's not linear. So if we looked at the ratios, we would see that the successive ratios, 0.4 over 0.08 would give us 5, 2 over 0.4 would give us 5, 10 over 2 would give us 5, so we see that it's exponential for the first one. Number 12, we first want to see if it's linear because that's the simplest one. We see if the successive differences are equal, and we see that they are right here. So we wouldn't see that number 12 is linear. And number 13, we see that the successive differences are not linear. We could check that if it's exponential too by finding the ratios, seeing if the successive ratios are equal. But for this one, we're going to check to see if the second differences are equal. So 3 to 1 would be -2. 1 to -1 would be -2, and -1 to -3 would be -2. So we see that this is a quadratic function right here. All right, last part of our notes. Determine which type of function the table represents. All right, so here's our form of our of our functions. Linear would be, remember, y equals mx plus b. Exponential would be y equals a times b to the x power. And quadratic would be y equals ax squared. All right, so for linear, we need to find the slope and the y-intercept. For exponential, we find the initial value and the growth factor. And in quadratic, find the value of a. And don't worry about, we won't be going any further than this for the quadratic formula. All right, so let's see. All right, so the slope would be the same for the, let me pull that down. For the linear, would be just whatever that successive difference is. All right, so to get from -7 to -5, we just had 2. -5 to -3, we just had 2. -3 to -1, we just had 2. -1 to, -1 to 1, we just had 2. So we see that this function is linear, number 1, and we see that the slope is 2. All right, so we need to find the slope and the y-intercept. All right, so what is the y-intercept? Where does the the y-intercept. Where does the function cross the y-axis? And we see that it would be right here at -1, 0, -1. So our y-intercept is -1. So the equation for this function, this table, this linear function, would be y equals 2x minus 1. This is our slope, and this is our y-intercept. All right. Now for number 4, if we work this out, we see that there's a difference here of -6, difference here -2, 2, 6. This is not linear. We can see that. But let's check our second differences. Difference between -6 and -2, 4. -2 and 2, 4. And 2 and 6, 4. So we see that this is a quadratic function. All right. So we need to find the value of a. All right. To find the value of a, we've got x and y intercepts right here. So we'll just plug these in. All right. Our y is 8 equals a times our x value, 2, squared. All right. So 2 squared would give us 4. and then we can just solve by dividing both sides by 4. So 2 equals a. So our quadratic function, or a quadratic equation for this function would just be y equals 2x squared. All right? So go ahead and work on the skills practice, or you can start working on your homework.